Alright, so last lesson, guys, we did look at factorising by taking out common factors. Okay, and I asked you to do that homework sheet. Today we're going to factorise difference of perfect squares. Now there is actually, before I show you, we did speak about difference of perfect squares when we were doing expanding. Okay, we saw those types of things when you saw a binomial product, and you got to the point where there's only, after you expanded and simplified, there's actually only two terms left in the expression. So there is a bit of a rule there. You can see for factorising difference of perfect squares, but I'll walk you through these 4 examples, and then that might become a little bit more clearer. Essentially, what you've got 2 squared terms. In this example, it's a squared and b squared, separated by a subtraction sign. The first example I'm going to show you guys, though, is, again, from the textbook, example 5. You've got x squared, which is a square term, x times x, and 16, which is a square number, 4 times 4, and there's a minus sign in between. So what we need to do is we're going to set up a binomial product, which is 2 sets of brackets. And essentially, at the front of the bracket is going to be the square root of the first term, and at the back end of the bracket is going to be the square root of the second term. Okay, so square root of x squared, x, yeah, good. So that goes at the front, or just inside, but the front of each bracket. At the back, square root of 16 is 4. Good. And then basically, you can see here in this example, in this rule, one set of brackets has an addition sign, one has a subtraction sign. It actually doesn't matter which one's which. You can have subtraction in the first bracket, addition in the second bracket. It doesn't matter, because when you expand it, you still get back to, if you did expand this, you still get back to that original expression. Okay, so that's basically as simple as it'll get today for you guys. Let's look at the second example, which is a little bit more complex from that first one. But essentially we've still got 2 terms, or 2 square terms separated by a subtraction sign. Set up your brackets. Okay. In my first bracket, at the front of my brackets is the square root of 9a squared. So what's the square root of 9? 3, good, thank you. Square root of a squared, 8, good. So that goes at the front of each bracket, and at the back of each bracket, so I've changed the colours here, doesn't matter. Square root of 4, 2, square root of b squared, is b. And plus and minus in between. Alright, simple as that. Alright, let's go on to the third example there. So 12y squared, take 1,450 is, actually before we do this one, I'll set up my brackets. Oh no, I won't. Is 12 a square number? No, it's not. Remember yesterday, what were we doing yesterday? Factorising by? Yeah, by removing common factors. And I think I said it, and I tried to repeat it a few times. The first thing you should look for when you're factorising is to remove common factors. So, this isn't a fantastic example, but there is a common factor between these 2 terms. Ronnie's trying to work it out now. What's the common factor between those 2 terms, Ronnie? 12 is a common factor. Alright, so essentially what I'm saying is 12y squared and 1,452 are both divisible by 12. So, what happens? Who remembers the process from yesterday? Taking out a common factor. Where does that 12 go? Good, in front of the brackets. Then inside my bracket. So 12 times by what gives me 12y squared? Y squared. Good. And what's 1,452 divided by 12? 121. Good. Now 121 is a square number, right? Yeah. So I've now got inside my bracket here the difference of perfect squares. So what I'm going to do is I'm going to set up the binomial product, like we have in the first two examples, but I'm just going to put the 12 in front of that binomial product. Right, just like that. So then what goes at the front of, so y goes at the front here, and then 11 at the back end, and then plus and minus, okay? So this was just one extra step. Remember, the first thing you should always look for is a common factor. So guys, today, when you're doing the questions, I think from memory it was question 6. This is an example of question 6. Before you can factorize difference of perfect squares, take out a common factor. Last example I'm going to do with this one is example D, which is x plus 3 all squared, take 4. Now, this is basically two terms. There's two terms here, x plus 3 all squared and 4. And they're both square terms because x plus 3 is essentially x plus 3 times by x plus 3. So the square root of x plus 3 all squared is actually, I know this sounds a little bit confusing, just x plus 3. And that goes at the front of both brackets, alright? Notice how there's no minus in here because it's just that term, because it's x plus 3 squared at the front of each bracket. Now I can put the plus and minus in. What's the square root of 4? 2. So 2 and 2. Is that it? Am I done? Ooh, why not? Oh. I can still make it look better because essentially inside, if I was to look inside those brackets, now technically these are really just two terms, but if I was to look inside the bracket, I could say technically, I could say, okay, I've got 3 terms inside that bracket. And inside that bracket, there are what we call like terms, yeah, or constant terms, which I can collect. So those two like terms inside the first bracket would be, yeah, positive 3 and positive 2, which would simplify to give me 5. Good. So x plus 5. And then the second bracket would simplify to be x plus 1. Good. All right. Beautiful. All right, so that's how you factorize difference of perfect squares. I'm also going to show you today factorizing difference of perfect squares using surds. Do you guys remember what a surd is? Good. What is a surd? Yeah, so we leave it as a surd because it's kind of like exact value. So remember when you're doing Pythagoras, if you have a number like, if you find the square root of 4, you can get a nice number like 2. But if you had the square root of 5, that's not going to give you a nice number, is it? It's going to give you a decimal or an irrational number. So what we're going to do is leave, in fact, what if I say it like this? We know that 4 squared is equal to what? 4 squared? 16, right? Which is 4 times 4 equals 16. Essentially, what is the square root of 16? 4. So I could write this as the square root of 16 times by the square root of 16, which is 4 times 4 equals what? 16. Okay? So this is, I guess, the premise we're going to use for factorizing difference of perfect squares using surds. So even though 16 is a square number, and I don't have to write it as a surd, I have in that example because I want to show you that if I had a number like 10, for example, so the square root of 10 times by the square root of 10 is equal to what? 10. And 10 is not a square number. So I can't write the square root of 10 as a nice whole number. So I'm going to write it as a surd. So, with that in mind, difference of perfect squares using surds. This is my first example. X squared take 10. 10 is not a square number. But if I set up my binomial product, x goes at the front. Well, the square root of that first term goes at the front. What goes at the back of those brackets?
Square root of
10. Yeah, root 10. Okay, simple as that. And then still the same, plus and minus in between. Does that make sense, Ron? All right. The second example is the same, but there's an extra step because I can't simplify that surd. Have you guys done simplifying surds before? Yes, no, some of you. Anyway, let's look at the second one. X squared take 24. Is 24 a square number? No, it's not. So let's set up my binomial products. I've got X plus and minus root 24. Now, square root of 24 can be simplified further. How? So how did you get that though?
So 24 is the product of the surds 4 and 6, and square root of 4 is 2.
So why did you choose? So why don't you choose 12? So why don't you choose? Ronnie just said 24 is the product of 4 and 6. 4 is a nice square number. Why did you choose 4 and 6 and not 12 and 2? So 12 and 2 are not. They're not square numbers, are they? But 4 is. So what you want to do is you want to find a factor, trying to find a factor of this surd that is a square number. We know that, as Ronnie said, 24 is a product of 4 times 6. And we know that 4 is a nice square number. So we can use that. So what we're going to do is write x plus, if we wrote this like this, so square root of 4 times 6, x take square root of 4 times 6. We know that the square root, oops, I don't want to show you that on my video. The square root of 4 is 2. So I can rewrite this now as, I know this is a little bit confusing guys, so bear with me, x plus, instead of root 4, I've got 2 times by root 6. Alright, and then x take 2 times root 6. Okay, so that's how we're simplifying a surd. Try and find its product with one of those numbers being a square number. That's why I didn't use, 24 is also a product of 12 and 2. But neither of those numbers is a square number. That's why we chose 4 and 6, because 4 was a square number, and we could change that 4 under the square root sign to a 2. Okay? Alright. Last example. They are getting harder now, guys. But the last example I'll do today is take 1. All squared, take 5. Gentlemen, thank you. So, set up your binomial products again. X take 1 at the front. X take 1 at the front. Plus and minus. Remember what goes at the back of my brackets? Root 5. Good. Hopefully you've all sort of seen that and been able to identify that. Now, can I simplify root 5? No, I can't. Okay, so none of its products will be a square number, apart from 1, and that won't simplify it anyway. Can I add, what can I do, minus 1 plus root 5 to simplify inside there? Or minus 1 take root 5 to simplify there, like we did over here in this example. Can I do that? No. Think of it as, one way I like to think about it, think of it surd as, think of surd as like a variable or a pronumeral like x or y. And, it's not a constant term, so we can't collect those terms. Alright? So that's as far as we'll go with that one. So lots of examples there, guys. I'll leave it up on the board for you for today, but I'll also publish it to Daymap, and you can use it to help you through.